Hello, this is Brian Silva, and today I'm going to show you how to find the intervals of a function's behavior. The problem we'll be doing is on page 314 of our books, and we'll be doing problem 3. Now, what this problem is telling us to do is to determine the intervals on which f is positive, negative, increasing, decreasing, concave up, and concave down. And we have to do it from f of x, which here is equal to the function of x minus 1 over the function of x plus 3. So the first thing we're going to do is find where f of x is 0 and where it doesn't exist. And here we see that f of x is equal to, for our numerator, that f of x is equal to 0, where x is equal to 1. And we also see for our denominator that f of x does not exist where x equals negative 3. Now, here we make a sign chart. Alright, and determine where everything is positive and negative. So we can split this so we can do the numerator first. Okay, now before negative 3, the numerator should be negative. Then after 3 it should be negative still. And after 1 it should be positive. Now let's do numerator. The denominator should once again be negative before 3, negative 3, though positive anything after. Well, multiply these up, and we find that f is positive before negative 3, negative after negative 3, and goes above 0 after 1, which means we have an x-intercept here. So now let's find our first derivative, which will determine where it's increasing and decreasing. So we're going to use our quotient rule, of differentiation, which should be that we should go like this, where the x plus 3 function minus the x minus 1 function over x plus 3, that's 3 squared, and which this should simplify to it being 4 over x plus 3 squared. Now let's do the sign chart again. Though as you can see here, because our numerator is just a constant, that f of x, the prime f of x is equal to 0 nowhere. Though our numerator is still somewhat similar, so prime of x does not exist where x is equal to negative 3 once more, holding constant with the original function. the sign chart again. This time just focusing on what's before and after 3. So 4 should be positive everywhere. And over x plus 3 squared. This should mean negative before negative 3 and positive after negative 3. We find that f prime is decreasing before negative 3 and increasing after negative 3. Now we know where it's positive and negative and increasing, decreasing. Oh wait a minute, am I being mistaken? Yeah. Okay, wait. What? Okay, I think here. Sorry. Okay, my bad. I forgot to notice the square root here. So that's really positive. So itty bitty things. So now we know where that's increasing everywhere, and we also know that it's positive and where it's positive and negative. So now all we have to do is find where it's concave up and concave down by using our second derivative. We should find, using the quotient rule again, on the sum on 4 over x plus 3 squared, and we should get it to be equal to negative 8 times x plus 3 over x plus 3 to the power of 4, which can be simplified to negative 8 over x plus 3 to the power of 3rd. Now, once again, much like our first derivative, the second derivative does not equal 0 anywhere, though also does not exist, where x is equal to negative 3. Now let's see. Now let's do one more sign chart and determine where everything's concave up and concave down. Negative 8. Sorry. Negative 8. I mean negative everywhere. And 1 over x plus 3. So that's squared cube. Cube should be positive before. Should be no. It should be negative before 3 and positive before negative 3 and positive after negative 3. And up, we see that we would see that our function is concave up before negative 3 and concave down after negative 3. So now we have our information. We can now state our intervals. So our function is positive on the intervals negative infinity to negative 3 to negative 3, and on 1 to infinity. Function is also negative on the interval. So negative on the interval. Sorry, I wasn't thinking. On the interval negative 3 to 1. Though you can't really reach 3. Our function is increasing about everywhere except for that one point, so we're going to make 2 intervals for that. Sorry. Increasing on the intervals negative infinity, negative 3, negative 3 to infinity. And now, thanks to our second derivative, we now know where it's concave up and concave down. So our function is concave up on the interval negative infinity to negative 3, and concave down. Now on the interval negative 3 to infinity. Thank you for watching, and carry on.